right. Is this on? I think it is. So my talk today is the technical debt trap. I got a bit of an introduction, but quick. I'm Doc Norton. As mentioned, CEO of CTO2. The really only thing I want you to see on this slide that's important is Doc on Dev. That is me everywhere. All the things whack Doc on Dev. So if you want to tweet at me or Facebook or LinkedIn or whatever, that's where you'll find me. So I've got a question for you folks. Technical debt's been around for quite a while, and I've been in a lot of conversations with people about it over the course of more than a decade now. When you hear that phrase, when you hear the phrase technical debt, what does that mean to you? Anyone? Just, yeah.
I mean, someone implemented some kind of hack just to bypass, just to cut corners or something?
Okay, so some kind of a hack that's been implemented to just cut corners. Yeah. Stuff we've written that we don't like anymore. Sure. All right, so something that we've written that prevents us from adding more features on top of that. I've got one here. All right, so a technical issue that's going to cost you money in the future, but you don't know when. So, there's a bunch of different perspectives on technical debt these days, and I think it's really important, and I think it's actually pretty interesting too, to look at kind of the origin of this metaphor. How many folks know where the metaphor actually came from? Do we know who coined the phrase? No? Okay, no worries. I do, and I will share it with you. So many of you probably know this guy. This is Ward Cunningham. If you don't know this guy, look him up. Pretty much everything you know about computers today traces back to Ward somehow, right? Everything that is extreme programming, Ward Cunningham. And I mean everything that is extreme programming, Ward Cunningham. Patterns, Ward Cunningham. The wiki, Ward Cunningham. So anyway, in 1992, Ward, in a white paper for Uppsala, was sharing an experience that he had with a client of his, and was talking about an explanation that he was giving to his client about some work that they were doing. And he said to this client, look, shipping first-time code is like going into debt, right? And it's fine. It speeds up our development as long as we pay that debt back really quickly, right? Just real promptly with some kind of a rewrite or something. The danger occurs when the debt's not repaid, right? And every minute on not quite right code counts as interest on that debt. Now, if you know Ward, there's a couple of things about this that are important, but let's start with, if you know Ward, if you've ever had a conversation with him, despite being fundamentally the founder of all things we know, he's actually a very soft-spoken, nice guy. He's very deliberate about his words, but because he delivers gently, we sometimes miss the message that Ward is actually trying to deliver. And what I want to do here is I want to pick apart this last piece of Ward's kind of description of technical debt. I want to look at the words that Ward is using here, right? Because I think his language is super intentional and maybe a little too subtle for some, or especially the way that Ward tends to deliver things. So the first thing that I notice when I look at this is Ward uses the word danger. He doesn't say the challenge, the problem, the hurdle, the complication, right? He says danger, which is closer to a fight or flight type situation than, meh, we got some debts, maybe we'll worry about it someday, right? The next thing is he says, every minute spent on technical debt is a danger. Not every year or every quarter, not every month, not every release, not every day. Every single minute that you have technical debt is a danger to your project. Now, what is technical debt? It is code that's not quite right. It's not a mess. It's not something that we slap together quick. It's not something that prevents us from building on top of it in the future, right? It is code that is not quite right. Every single minute we have something that is just slightly off in our system, it is a danger to the product. Now, I'm also here to tell you that per Ward Cunningham, technical debt is good. How is that possible? How is technical debt good? Well, the way that Ward originally intended, what he's talking about here is a strategic design decision. Right? What he's saying is like, look, this is a thing that we do. It is a way for us to get rapid delivery so that we can get fast feedback, so that we can figure out what our design is supposed to be and to correct it. See, what he was explaining to his customer wasn't why they had shoddy code. What he was explaining was refactoring and early release. See, they wanted to know, I don't understand. You said the code was done, and now here it is an iteration later, and you're working on it again. If it's done, why are you working on it? So, oh, well, we released something lightweight. We got feedback from the customer. We learned what it was that they wanted, and we are now adjusting the design to match their needs and expectations. And the system that he was working on was the YCash portfolio management system. So his client in the late 1980s was a financial institution that understood debt to be a risk, to be a thing you didn't want to take on unless you fully understood what was happening. So the metaphor was perfect for that client, and it made sense, right? Now, sometimes it's not a strategic design decision. Sometimes what happens is it's actually an indication of learning. So in this case, what happens, so there's one case where we might know that we're going to sell 1,000 different variants on this one product. But we also know that the large black version is 80% of all revenue. So why not just launch it in that version, and then we'll come back later and add the code that allows us, right? So in one case, we made a strategic design decision. In another case, sometimes what happens is we launch a thing, we think we know what it's supposed to be, we think we know what the customer wants, and it gets out there, and it turns out that the market tells us something different, and so we have a learning event, right? We have this indication of learning that we say, oh, well, we thought it was X, but it turns out that it's Y. And so now we know the requirements are this, but our implementation is here. We've got this gap between what's implemented and what's required. That is our technical debt, right? So if it's an indication of learning, we now know what it is that we need, and we know that our implementation doesn't match, so we know what it is that we need to do. Now, the last thing that technical debt is, and I've said this already, but I think it's super important, so I want to point it out. It's a metaphor, right? The phrase technical debt is just a metaphor. It's a metaphor for what? Fundamentally, it was a metaphor for here be danger. If we have technical debt, every minute we have it, there's danger. Now, metaphors are amazing, right? These things are so super helpful. They absolutely rock. We reason through metaphors. This is how we can convey ideas in domains that we don't share, right? If I know a lot about this thing over here, but you know very little about it, but we both know something about this thing over here, and I can find similarities between the two, I can tell you something and say like, oh, well, this is like blah. Or I might even say it is blah. For example, code that I'm refactoring is technical debt. And because you understand debt, we've now got a common language that we can use to talk about this thing. the challenge here is that you've got the actual object, and then you've got some fictitious replacement. And after a while, what ends up happening is we're talking about the replacement as if it were the real thing. And we start talking about the characteristics and properties of the replacement, still as if we're talking about the real thing. But we're not anymore, right? We're talking about a metaphor. We're talking about a stand-in. And I'm sure you've been in some of these conversations where, somebody on the team says something like, we can't keep doing this. It's like you want us to refuel the car while we're driving it down the road. And what they're really saying is like, we can't keep adding features while we're trying to clean this thing up or whatever, right? But 10 minutes later, you're actually having a heated debate about the possibility of pulling another vehicle up beside it and actually running a fuel line over, right? We're not even talking about the code anymore, right? All we're talking about is the metaphor. And when this happens, I have a name for this, right? I call this Metaphor-phosis. We start with this idea, this one thing. And there's a word in there, technical debt. Well, we understand what debt is, right? So we start to talk about debt. And we know what that means. At least we think we do. And unfortunately for us, between the 80s and the 20-noughts, right, between then and now, something else happened in the market. Something happened where, leverage went from a thing that you don't really want to do to a thing that it's shameful if you don't have a ton of it, right? We've somehow gotten to the point where, debt is a matter of pride in business almost, right? You should be using other people's money and whatever else it is. So all of what ends up happening is we're talking about technical debt as if it's real debt, and we're making the thing more and more and more complicated. And the next thing you know, we're talking about short-term and long-term and voluntary loans and student loans, and we're talking about loan sharks and inadvertent reckless debt in the third quadrant, which, by the way, is a thing that we're going to talk about. Right? And so after a while with Metaphor-phosis, the conversation doesn't even make sense anymore. We're not talking about anything that we were actually talking about at one point. Now, this became very pervasive, right? So this leaked into the community until eventually our own leaders bought into these concepts. Now, I know most of these folks, and I respect all of these folks, but these are actual phrases in the late 80s, early 90s that these people were saying about technical debt. In the late 90s into the early 2000s. And eventually, this kind of debate came about. Right? In early 2009, I happened to be working at ThoughtWorks, and I was in Chicago on the beach. And so that just basically means I wasn't on a project at the moment, and I was allowed to do stuff. And I was very fortunate. I was on the beach at the same time that Martin was actually visiting the Chicago office, and he and I got into this debate about technical debt. And I wrote an article that saying, messy code is not technical debt. Shortly after that, Uncle Bob wrote a similar article. Shortly after that, Martin came out and said, look, we're having this huge debate about debt, and it's not very valuable. What's happening is we're talking about, is this thing debt or is this thing not debt? And what I really think we should be talking about is, where did the debt come from? Right? So he wanted to talk about what was the source of it. And so what he came up with was the technical debt quadrant. How many of you are familiar with this quadrant? Couple. Okay. So the way he was thinking about debt, and I like where he was going with this to some extent, is he said, look, debt comes from different types of behavior and different types of intent. So it can be from prudent behavior or from reckless behavior or somewhere on that continuum, right? And it can be something that you actually do deliberately or something that you do inadvertently. So maybe you did it on purpose. Maybe you did it by accident. And if we look at this quadrant, we can start to kind of break this down into different things we might hear or see as people are engaging in these behaviors. So you said, look, if it's reckless or inadvertent, reckless and inadvertent, it's probably about like not knowing about good architecture or other things, right? And so you don't know that you're doing something incorrectly. Now, reckless and deliberate, that's a little bit different, right? That's like you're skipping good practices just to save some time or in hopes that you're going to save some time, right? You know maybe you should be doing this, but you skipped it anyway. Then we get to the prudent side, and this was interesting for me because it took me a while to get my head around the idea that you could accidentally do something well, right? Like this prudent inadvertent thing. But I understood this, I came to understand it better. But Martin described this as you realize a better approach after the fact, right? So we kind of talked about it. It's our indication of learning, right? So that's our indication of learning. Now we know how we should have done it. And then in his own words, he said prudent and deliberate, and this is per Fowler, is something, for example, we must ship now and deal with consequences. So this kind of became the new talking point for technical debt for a while, but it's actually for a fairly short period of time. Because Cunningham kind of came out of the darkness and he released a video on YouTube, and he basically said, yeah, I think you folks misunderstood me, and most of you have this wrong. Many of you have explained this debt metaphor, confused it with the idea that you could write code poorly, right? And maybe clean it up later. He says, yeah, this is not at all what I meant. In fact, the ability to actually pay that debt back depends on you writing code that's clean enough to be able to refactor as you come to understand your problem. And once again, Ward and his very deliberate choice of words, I think it's interesting. Code that is clean enough to be able to refactor. What is refactoring? Anyone? Cleaning up code? Rewriting without changing the functionality, right? So refactoring, when we refactor code, we are changing the implementation, but we are not changing the behavior. Now, if you change a piece of code, if you change the implementation of that piece of code, how do you know that you didn't change the behavior? You have tests, right? So Ward is telling us that the ability to pay back technical debt depends on you having clean code that is well tested. Ward is actually telling us that clean code is a prerequisite to technical debt. You cannot have clean code, you cannot have technical debt unless you have clean code and tests. He comes out a little bit later on Twitter that same year, kind of his last sort of hurrah on technical debt. He said, all right, fine, you guys want to go with this metaphor? Let's go with it. Dirty code is to technical debt as a pawnbroker is to financial debt. Don't think you're ever going to get your code back. So a lot of people go, well, all right, I'm a little confused now. Like, there's this thing that I thought was technical debt, and now I'm not sure if it is or isn't. According to this definition, like, that can't be technical debt. How do I know if I have technical debt or not? All right, excellent question. So here's a heuristic for you. Do you have technical debt? Well, ask yourself a couple of questions, right? Or a few questions. Is there a learning opportunity, right? Or event, right? Learning opportunity or learning event. Is there an actual plan for paying back the debt? Is the business actually informed? Right? And I don't mean like, well, we told them we were incurring technical debt. I mean, do they actually know what this means and what's going on, right? And these last two, is the code clean and is the code tested? If you can't answer yes to any one of those, then you do not have technical debt. You have something else. And there's a couple names for it. One, and probably the most common that I've heard, is you have a mess. Now, my favorite is actually that you have Cruft. It's an unpleasant substance, a result of shoddy construction, or actually, by definition, redundant, old, or improperly written code. That is Cruft. I make sure that when I'm in an environment, when I see Cruft, I call it Cruft. When I see technical debt, I call it technical debt. Now, here's the weird part about technical debt. You know how you see it? It's a story in the backlog. Right? It is an indication of, here's what we should have, here's what we have, here's what we should have, here's the story that gets us from where we are to where we need to be. That's it. That's technical debt, according to Ward. So I've given this talk a number of times. I've been involved in conversations around this topic now for well over a decade. And one of the things I hear quite often is, all right, that's cool, dude. Like, I hear you, you've got an opinion, blah, blah, blah. Some old white dude, you're also an old white dude, blah, blah, blah. Isn't it really just semantics? Like, aren't you just, replacing this word with that word and then acting like, you know better? I'm going to argue that it's not just semantics. And here's why. If we agree that technical debt is good, and we agree that quick and dirty is technical debt, then by the associative property of technical debt, we agree that quick and dirty is good. And I cannot agree to that in almost every environment that I've been in almost every corporation. When I see quick and dirty, there is no recovery plan. There is no way to get around it. It is not a good thing for that company. Now, I'd mentioned before the debt quadrant, right? And I mentioned a little bit that like it kind of, I didn't feel quite right about it. Something was a little wrong. We debated for a while. Not that I was going to influence Martin in any way, but we debated for a bit. And I finally kind of took another look at it and started to realize, all right, here's the things that bug me about it, right? So the first one, this upper right-hand corner, deliberate and prudent. One of the challenges I had was with this, we must ship now and deal with consequences. That really doesn't sound prudent to me, right? So how would I have worded that differently? Well, what I would have done, I think, is I would have said, let's deploy and gather more information, right? That's what we're doing, ideally. We are deliberately creating a learning opportunity, right? So rather than dealing with consequences, I think focusing on learning. But that didn't do it for me. There was still something about this that just didn't quite feel right, and I couldn't figure out what it was. And I finally kind of zoomed out and said, okay, wait a minute. This feels all right, like, oh, it's just technical debt, and sometimes it's reckless, and sometimes it's deliberate, and sometimes it's prudent. I thought, all right, what if we took this metaphor and we looked at it in a different profession? Does it hold up? So technical debt in other fields. All right, well, what's it look like in construction? Right? Oh, we incurred some structural debt. We just had to, meet the deadline, so we should probably discuss that debt and set a plan for paying it back later, right? Okay, well, what does it look like in automotive? We incurred some mechanical debt. We had to do it to stay in budget. We should probably get some metrics around that and make sure we pay the debt down in the future. What does this look like in the medical field? Right? Can you imagine this? Oh, yeah, you see, we incurred some health debt during the surgery. It's kind of like you paid for the surgery with a credit card instead of a home equity loan. Right? When we look at this in other fields, suddenly the metaphor, as we've kind of moved it, right, doesn't really feel quite right anymore. In fact, what are these things, right? So the two on the right, I'm going to say they're reckless, and I'm going to go out on a limb and say those were also deliberate, right? They didn't accidentally build a wall around the toilet, nor did they accidentally put that, right? Those were deliberate, but they're definitely reckless behavior. Now, I'm going to give them the benefit of the doubt. I'm sorry, my right. on the other side and say, while reckless, that was probably accidental, so that's reckless and inadvertent, right? So on your left-hand side. Okay, cool. Now let's put those back on the technical debt quadrant. That's where those go. All right. Now, I want you to be honest with yourself, and I want you to think about what those things actually are. What do they actually represent? Sure, you can label them deliberate and reckless, or you can label them, reckless and inadvertent, right? But they're actually irresponsibility and incompetence. You did the wrong thing on purpose, or you didn't know any better. Right? That's what those actually are. So on this quadrant, the only things that are actually technical debt are that behavior which is prudent, the result of doing the job well and either creating a learning event or, deliberately, or discovering one after the fact. All right, a bit of a break here. I know this talk gets a little bit preachy, at least I feel like it does. It's by far the most kind of preachy talk that I give. So I want to see, does anybody want to play a game? Let's take a break here and let's just play a game. I've got a game for us. It's called Cruft or Debt. 3 rounds. They will get progressively harder. Round 1. I'm going to show you a piece of code, and you tell me, is this Cruft or is this debt? We ready? What do we got there? Cruft. Cruft, right? All right, show of hands, who in the audience doesn't code for a living and knows that's Cruft? Yeah, come on, right? All right, so let's take a look at this real quick. Oh, and all right, a bit of a aside, but I think it's kind of important. I got this one in particular off of a website called the Daily WTF. All right. How many of you are familiar with Daily WTF? All right, so WTF, by the way, is worse than failure, just in case you thought it was something else. So Daily WTF is run by Alex Papadimoulis. And Alex Papadimoulis and Jake Vinson started this site, many years ago. And Alex now makes a full-time living off of advertising on this site and then builds products on the side. So when the site first launched, I heard about it through some of my employees at work. They were actually looking at it one afternoon and just laughing their asses off. And I asked, what is this? They're like, oh, it's the Daily WTF. It's so great. Oh, my, whoa. Okay. So I looked at it. I'm like, yeah, that's pretty funny. About the third day of looking at it, I see this chunk of code that looks super familiar. And I realize, I'm pretty sure that's ours. So I start asking around, and this is when I learned that Alex Papadimoulis was the owner of Daily WTF. See, Alex worked for me at AmTrust Bank in Cleveland, Ohio. And he had been so frustrated with managing other people's crappy code that he started copying it out of our source repos, anonymizing it, and putting it up on this website. But you can only anonymize so much when it's that bad, right? So this is actually one of the pieces of code that was in that bank's website back in the day. So let's just break this down, right? First of all, let's get rid of these curlies by the way, yes, Cruft. So all right, get rid of these curlies. That helps a little bit, right? Now, you don't have to read through all of this, but basically this thing is going through, it's iterating through tons of tables in a bunch of different data sets, and it's actually iterating through column names, even though it knows what column it's looking for. So there's a bunch of just looping in here that's totally unnecessary. So we can get rid of all of that to help clean it up. Come on now, there we go. Right, so that's a little bit better. And then we can actually introduce a little bit of abstraction here, which I'm not going to show the code for because it's something that an ORM can do. But we're going to create some classes that receive data sets and return collections of objects to just help like clean this up a little bit more. Just trying to get down to just like what's the essence of this thing, right? So a little bit of that. Okay. So now we can almost see what it is this thing does. And if you actually read through, it looks like what it's doing is it gets a list of skills for an agent. It compares them to a list of skills in a queue and then calls set agent queue skill. And it actually turns out that all it's basically doing is building a list of like what agents have what skills, right? Which, if you think about it, should really just be a view in the database. None of this code should have ever existed, right? So that's how valuable that stuff was. Okay, round two. I said they're going to get harder, right? So I'm going to show you another piece of code. Same thing. Is this Cruft or is this debt? What do we think? Cruft. I'm getting Crufts. What's that? You got a debt? Like I said, it was going to get harder. All right, so I'm going to go with this being Cruft as well. So we're going to read that line up to indicate that it's Cruft. All right, so for those of you that said it was Cruft, why? Okay, no tests, right. Fair enough. None of these actually show tests. No, somebody always catches me on that technicality. It's true. Right, so let's let's assume that there's actually tests for it, right? So if that's the case, then does anyone still consider it Cruft? Yeah.
The meaning of this, there's essentially three different conditions in the if, and which, like, what each one means isn't clear.
Right. Right. So high cyclomatic complexity, right? Lack of clarity. You don't know what it is that it actually does. It doesn't reveal its intent in any way. Right. So luckily, there is a universal fix for that problem. There. Still Cruft? Yes, it's still Cruft, right? So one of the things I noticed about this, and I mean, obviously this is code that's just taken from some repo somewhere, right? We don't know a whole lot about this, but one of the things that we do know is that it's not the customer, because there's a bunch of customer dot, yeah, blah, 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 right? But we're interrogating the snot out of the customer. So maybe there's some misplaced responsibility here, right? Maybe there's something that this code could actually be in the customer object itself. I'm willing to bet that if it was moved over there, some of these conditionals would fall out, or at least would be easier to read, right? So I would certainly argue that's at least one thing that can happen is this can be pushed into the right place, which then basically reduces this down to if customer is federally regulated, right? So we're not seeing some of the other code that happens, but we can definitely clean up at least this piece of it quite easily. All right. Did I do a 2 again? This should be a 3. My apologies. So Cruft or debt. Now, this is a bonus round. If you can name the movie, you get bonus points. They're worth nothing, but you'll get them. All right, we ready? Third round, final round. Cruft or debt? That's right. Monty Python, Quest for the Holy Grail. Cruft or debt? I got a couple of Crufts, I got a couple of debts, and I got nobody that's really convicted. Again, we can assume tests. Debt. Debt. So I'm going to label this one debt. I'm going to give it the blue line there, right? But the truth of this one is, it depends, right? This starts to come down to what are your team standards, what are your agreements, right? If you are a diehard Uncle Bobber, this is Cruft, right? Polymorphism will fix this. But for most of us, what do I got? 3 conditions? Do I know the domain well enough to know that I'm never going to have a 4th condition? Is it really necessary to make this thing extensible when I kind of know there's only 3 in the whole world, right? Like, so it just really depends on like how much do we know about the domain? How much do we, what does the team feel becomes too much? If there were 27 cases in this statement, then I would argue that this is Cruft, period, no question asked, right? But it's only 3, it's kind of, so it really comes down to kind of what does the team agree on more than anything else. And the thing is, if we look at this, right, what's a way that we would clean this up? Right, if we want to get rid of a conditional, we can use polymorphism to do that, right? But, and there's code that's missing from this. Obviously, I'm just showing kind of that, like, even with leaving out some of the code that would actually be necessary for this to work, we can see that I've added a bunch of code to this thing in an effort to clean it up. Now, the cleanup is because it's now extensible, right? And all of the behavior has been isolated into one and only one place, and so there's a bunch of goodness that's happened here, but it's really kind of a toss-up.
Could be less of a toss-up if you have that switch over multiple places where you switch on the same part, for example.
Yeah. Right. Right. So yes. So if now we're talking about even just the simple fact that the switch statement is one thing, right? We've got high semantic complexity, but now you're talking about actually we're repeating ourselves in the code, right? So the code is no longer dry because we basically, if we haven't moved this responsibility in the right places, we may end up with that conditional multiple times. Yeah. Oh, and yeah. So there may be multiple properties that we're switching on. Yeah. So, I mean, yeah.
But your point is, can I read it so I can refactor it? Then we can. So we'll be
So,
there.
say it again.
If your point is, can I refactor it because I can understand it, and that hence it's dead, then for that reason it would be dead.
Then that would be dead. So if the point is that you can refactor it because you can understand it, then it would be dead. Yeah, I think in this case it comes down to more of I agree that this is debt. At least in most environments, this is what would just be considered like, hey, this is a reasonable implementation of this design. We know that we could have a better design, better by whatever by a certain level of standard, right? Right. So that's why I think it's really kind of rides the line. But there's plenty of stuff that we know is actually Cruft. And here's the deal: don't do Cruft. Right? Just don't do it. You're a professional developer, and professionals behave ethically, and they do their jobs well, right? And you're going to write unintentional Cruft. You can't help it. It's unintentional, right? Or inadvertent, as Martin might say. And you're going to have to clean up the existing Cruft, because your intent doesn't alter your responsibility. Sooner or later, you're going to have to clean that stuff up. Now, this talk is called the technical debt trap, so I want to talk a bit about the trap. And the trap is fundamentally, in most environments, if what we're doing is we're cutting corners and creating Cruft in order to move quickly, we've got a couple of problems. The first is that what we've done is we've set a precedent for speed over quality, right? Now, in most environments these days, some executive has decided that we need to install the Agile. And so that's the thing that we're doing now, right? And they read one of the books, probably one of the latest books. And in that book, it explained to them that when you take these teams and you put them together and you have them be all agile, sometime around the 3rd or 4th iteration, they get faster. There's no explanation of how or why, just it happens. So there's an expectation that the team is going to move faster, right? But the Cruft slows you down, which means you've got to write more Cruft to keep up. And what happens? What happens is eventually we ask permission to do our jobs correctly. Now, we do this in very crafty and intelligent ways, right? It's very infrequent that we actually go to the boss and say, please, sir, may I do my job correctly? Usually what we do is we say things like, Java 1.6, blah, 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 Java 1.8, blah, 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 must do rewrite. And the boss goes, I don't understand. And so we get the permission to do the massive rewrite, right? And we even convince ourselves that this is actually necessary. But it usually has nothing to do with the capability of Java release whatever or framework yakety schmack, right? What it actually has to do with is like, we're scared to death of our own code. So how do we deal with this, right? What do we do? So if we want to manage this Cruft somehow, so we don't get ourselves into this situation, how do we manage Cruft, right? And there's a ton of different ways of doing this. I'm going to go over just basically two strategies. I'm going to go over the number one failing strategy that I see, and that is this concept of a cleaning iteration. How many of you have these cleaning iterations, right? Where what we do is like, we just run top speed, and then every once in a while we stop and we clean up all of the mess, and then we just go right back to what we were doing before, right? The challenge with these things is, you're scheduling an iteration to actually clean the code. You're deferring quality until those cleaning sprints, right? And then you're focused on speed over velocity at all other times. And there's an interesting phenomena. Every time you finish one of those cleaning iterations, there is a heavy pressure backlog of stuff that needs to be done because you just took 2 weeks or a month or even longer to clean up stuff, right? And so what happens, this is an old study, but what happens is this. We've got 3 lines in this graph. The bottom line is basically a code base that's been cleaned as it's gone along. And what we're looking at is the amount of time it takes to make a change in the code base, right? So the green line is a code base that has been cleaned as we've gone along. We can see the time is actually going up, right? But it's because the code base is getting larger and larger. You can no longer fit the model in your head. It's harder to actually make changes just in general. The black line is a code base that fundamentally just doesn't get cleaned, right? And you can see that it is about to hit that inflection point where it just basically goes to, you can't deliver any code anymore, right? The purple line is what happens when you do these cleaning iterations. In the beginning, you're basically creating Cruft at the same rate as anyone else. Then you take a little break, and then you just create more Cruft, and then you take a break, and eventually you can't possibly clean and keep up. And so you're really fooling yourselves, right? There's these brief periods of time where the code is a little bit cleaner, but then it rapidly gets messy again, right? And a lot of folks looked at this and said, well, all right, if this is time in years and it's going to take 10 years before the code base becomes basically unusable, who cares, right? I'm not going to be working here anymore. Well, this study was done in like the 1990s, right? And we've all kind of been here. Like back then, if I had been working in C++, I could have been doing that for 15 years, and I got 15 years to go, and I'm retired, right? And I could probably be in that one version. Today, things change much faster. This graph has condensed. It's now 2.5 to 3 years, and you're at that inflection point of like, we can't keep up. So there's only one winning strategy, and that is to actually clean constantly, right? Don't make an intentional mess. Monitor your technical debt. Frankly, monitor your Cruft, right? Follow the Boy Scout rule. You know what that means? What does that mean if you say that?
Leave the campsite cleaner than you found it.
Yeah, leave the campsite cleaner than you found it. Leave the code base cleaner than you found it, right? Remember, quality is your responsibility, and never ask permission to do your job correctly. If we just clean a little bit every time we're in there, the thing that happens is we're always cleaning the most important code. It's the code that we're currently working on. The more we work on it, the cleaner it gets. So the stuff that's like been sitting around forever and no one works on it and it's all crufty and nasty, but nobody needs to touch it, it's okay if that stays nasty, right? As long as it works. Monitor your Cruft. There's a bunch of different metrics around this. I look at coverage, complexity, coupling, and then in the .NET environment, there's the maintainability index. But whatever it is that you're looking at, here's the most important thing about actually monitoring this. One, actually do it. Get quantifiable objective numbers that show the quality of your code, right? Introduce those into the conversations. If you've got retrospectives, that information should be in there, right? If you're doing planning, that information should be involved in that. But what's really important here is monitor trends, not points. It doesn't matter how much coverage you have. What matters is it getting better? Is it getting worse? Is it staying the same? And is that what you expected based on your current strategy, right? Just worry about how it's trending. Don't set targets for coverage. All that's going to do is create a perverse incentive. It's going to create weird behaviors in the environment. If you say, we must hit 100% code coverage, you're going to get tests that have 0 value, but ensure that the code is being exercised, right? You're going to have tests against code that hasn't been changed in 10 years. What good is that, right? Quick recap. Technical debt is a strategic design decision. It requires the business to be informed and includes a payback plan. Cruft happens. It needs to be monitored. It needs to be cleaned. It is not technical debt. And the actual message of this entire talk, the one thing that I want you to take away, if nothing else, never ask permission to do your job correctly. Thank you.